Hello everyone, myself Ved, and today we are going to discuss this question. So we have a specific example of a biological methylation reaction that uses a SAM, is the conversion of noradrenaline, which is norepinephrine, to adrenaline, which is epinephrine. The reaction uses SAM to provide the methyl group. So as you can see here, this is SAM molecule and this is SAH, and breakdown of a glycogen in the body, primary fuel sources. You may have felt this adrenaline rush when preparing for a challenging activity. Adrenaline is about 6 times more potent than noradrenaline. So it's more about methylation reaction here. The key point, methylation means addition of methyl group. Okay. So as you can see in the chemical equation, if you look at here, this is SAM and this is norepinephrine. If you compare these two molecules, and in the product side you can see, look at here, this is NH2, this is NH2 here we have, and here we have NHCH3. Clear? Means extra methyl we have, and this sulfur have a methyl. This bond means methyl and this sulfur is without methyl. So what is happening in this chemical equation? We have the addition of methyl in the final product. It's not just a addition. Basically here we have a 2 hydrogen, but here we have just 1 hydrogen and 1 methyl. So this is more about substitution reaction, means in place of methyl, nitrogen grabs this methyl in this way and this bond is going to break. So that's why sulfur is neutral and this nitrogen have a methyl group. And this kind of reactivity is called substitution, which is nucleophilic substitution, which means nucleophile substitutes this hydrogen. Okay, this methyl is going to connect with this nitrogen. That is called nucleophilic substitution. So look at the question here. The very first question is, what is the classification of The question is, what is the classification of epinephrine? Let me zoom this. So it's talking about epinephrine classification. So the amine classification in epinephrine. So look at the example. This is epinephrine and this is nitrogen, which is amine here. So nitrogen's degree depend on number of carbon-carbon connectivity. If nitrogen is bonded with 1 carbon, then that is primary amine, and if nitrogen is bonded with 2 carbon, that is secondary. Similarly 3, tertiary. So this nitrogen is surrounded by 2 carbon, which means this one is a secondary amine. This one is a secondary amine. Okay. Same here, you can see this nitrogen is bonded with just 1 carbon, so this one is a primary amine. And same thing you can do with the alcohol. Alcohol degree depend on the carbon bonded to the OH. For example, suppose we have a carbon and here we have OH. So the OH degree depend on this carbon's degree. If that carbon is primary, alcohol would be primary. If that carbon is secondary, alcohol would be secondary. And that carbon is tertiary, alcohol would be tertiary. So this carbon is a secondary carbon because this carbon is bonded with 2 extra carbon, one in the left, one in the right. So this alcohol is a secondary alcohol. So same here, you can see the OH is bonded to this carbon and this carbon is surrounded with 2 carbon, one in the right, one in the left. Always look at the very first neighbor. Okay. So 2 carbon, which means secondary. Same here, you can see this one. This OH is also bonded with the carbon and this carbon is surrounded by 2 carbon. So that would also be secondary. This one also secondary because carbon is secondary. Classification of carbon does not depend on double, triple bond. It depends on number of carbon directly bonded to that particular carbon. Okay. So here in norepinephrine, every alcohol is a secondary. And in epinephrine, same, alcohol bonding is remains same here. So alcohol in epinephrine is also secondary, and in norepinephrine amine is a primary, and in epinephrine amine is a secondary. So as you can see, epinephrine we have, and we have to figure out amine. So epinephrine is this one and amine is secondary. So answer would be secondary. How much secondary alcohol in the norepinephrine? As you can see in example, we have just 3 alcohol and they are all secondary. So the answer would be 3. Now the next question. Which reaction takes place to produce SAH into SAH and epinephrine? We have to find out the reaction name to produce SAH and epinephrine. And I told you already, this is a substitution reaction. As you can see, nitrogen is going to attack on that carbon and this bond is going to break. So in place of a hydrogen, we have a methyl, and that is called nucleophilic substitution. So directly you can say it's a substitution reaction. It's a substitution reaction. In addition reaction, only molecule add, not substitute any of the atom. In elimination, loss of some groups, sometimes we can say removal of halogen, water, whatever. And oxidation means addition of oxygen or removal of a hydrogen. Now the next is how many chiral carbon in SAM molecule. So first I would like to tell you chiral carbon. So a carbon which has 4 different things, that is called chiral. A, B, X and Y. So you can see this carbon have 4 different things. So this carbon is a chiral carbon. So whenever any carbon have CH3 group or CH2 group or carbon double bond carbon or carbon triple bond carbon, then do not check chiral center on that particular carbon, because here we have 3 same hydrogen, here we have 2 same hydrogen, here we have double and triple bond, which means there is no 4 different bonds because it already have a double bond. So if you look at the SAM molecule, this one is the SAM. So look at the centers. So as you can see, this carbon, if you look at, here we have a hydrogen. This side a carbon have OH, this side only oxygen, this one is a nitrogen and this one is a hydrogen. So this one is a chiral carbon. Okay. This one is also chiral because again we have a 4 different things, hydrogen, OH, this carbon have OH, and again we have an extra carbon with the CH bond. So this is also chiral. This one is a chiral. No need to check on that carbon because this is CH2. This one also CH2, this one also CH2, but look at this carbon, nitrogen different, this CO bond is different, there is a hydrogen if you balance, and this is a CH2 molecule. So this carbon also have 4 different things. So I think it should be 1, 2, 3, 4. I think it should be 4. Okay, look at once again. This carbon is 1, this carbon is 2, this carbon is 3. Yeah, there is a one more, this carbon, sorry. This one also have 4 different things. So 1, 2, 3, 4, and this carbon of amino group is a chiral carbon. So overall we have 5 chiral carbon. So the answer would be 5. Thank you so much. This is all about for organic chemistry, and we have a question from stereochemistry, some reactions and some basic one. Thank you so much.